Welcome to Cool Fire News, the podcast where we dive deep into the world of technology and electronics. I'm your host, Siri, and today we're exploring the fascinating realm of digital electronics, focusing on two fundamental types of circuits, combinational and sequential logic circuits. These circuits are the backbone of all digital systems, from simple devices to advanced computers, and understanding them is key to grasping how modern technology works. Let's kick things off with combinational logic circuits. These are circuits whose output is determined solely by the current inputs. They do not have memory and do not depend on past inputs. Essentially, they perform specific logical operations on their inputs to produce an output. One of the simplest examples of a combinational circuit is the half adder, which adds two single-bit binary numbers and provides a sum and a carry bit. The half adder uses an XOR gate for the sum and an AND gate for the carry. When we want to add more complex binary numbers, we use a full adder, which can add 3 bits, including the carry-in from a previous addition. Another key example is the multiplexer, often called a MUX. A multiplexer selects one of many input signals and forwards the chosen input to a single output line, based on the values of its control signals. This makes it essential for data routing and signal selection in digital systems. Now, let's move on to sequential logic circuits. Unlike combinational circuits, sequential circuits have memory. This means their output depends not only on the current inputs but also on the history of inputs. In simpler terms, sequential circuits can store information and have a state. Sequential circuits can be divided into synchronous and asynchronous types. Synchronous circuits use a clock signal to coordinate changes in their state, making them predictable and easier to control. Asynchronous circuits, on the other hand, do not rely on a clock signal and can change state at any time, depending on the inputs. A fundamental building block of sequential circuits is the flip-flop. A flip-flop can store a single bit of data and comes in various types, including SR, set-reset flip-flop, D, data flip-flop, JK flip-flop, and T, toggle flip-flop. For example, the D flip-flop captures the value of the data input at the moment of a clock edge and holds it until the next clock edge, making it perfect for data storage and synchronization. Another important sequential circuit is the counter, which counts pulses and can be used for measuring time intervals, frequency, or the number of events. Counters can be binary or BCD, binary coded decimal, and can count up, down, or in both directions, depending on their design. One of the more complex forms of sequential circuits is the finite state machine, FSM. An FSM is a computational model used to design both hardware and software systems. It consists of a finite number of states, transitions between those states, and actions. FSMs are used in a wide range of applications, from traffic light controllers to computer operating systems. So, how do these two types of circuits work together in real-world applications? In a computer's central processing unit, CPU, combinational circuits are used to perform arithmetic and logical operations, such as addition and subtraction. Sequential circuits, on the other hand, are used to manage data storage, control signals, and the sequencing of operations. Designing these circuits requires a good understanding of both the desired functionality and the practical constraints, such as speed, power consumption, and cost. Engineers use various tools and techniques, like Boolean algebra, Karnaugh maps, and state diagrams, to optimize and implement these circuits efficiently. As we wrap up today's episode, it's clear that combinational and sequential logic circuits are crucial components of digital systems. From the simplest gadgets to the most advanced computing devices, these circuits make the digital world possible. Whether you're an aspiring engineer, a student, or simply curious about technology, understanding these concepts will deepen your appreciation for the devices we use every day. Thank you for joining us on Cool Fire News. If you enjoyed this episode, please subscribe, leave a review, and share it with your friends. If you have any questions or topics you'd like us to cover, reach out to us on our social media channels. Until next time, keep exploring the fascinating world of technology.